Good day, students. In this clip, we're going to be going over some examples on logarithmic differentiation. So the task is to find the derivative of the following functions. Okay, so let's write it down. Find the derivative of the following functions. All right, so for question number 1, we have the function y equals 3 minus x raised to the root x power. Okay, we can clearly see that this is a good candidate for logarithmic differentiation because you have a situation where a function is being raised to a function. Okay, the power of this base function is a function. Alright, so to use logarithmic differentiation, step number 1, we're going to take the natural logarithm of both sides of the equation. So we'll take natural logarithm of the left side, ln y, equals the natural logarithm of 3 minus x raised to the root x. Okay, now using the power property of logarithm, I can power down this function, which is an exponent, so I can power this down. So we're going to have the natural logarithm of y equals the square root of x times the natural logarithm of 3 minus x. Okay, now we can make use of the product rule to evaluate the derivative on the right side, and then we're going to use chain rule and implicit differentiation on the left side. Okay, so if I differentiate this ln y, I'm going to have 1 over y times, that's the derivative of natural logarithm of y times y prime. Okay, on the right side, I'm going to use the product rule. We know that uv prime is equal to vu prime plus uv prime. If I apply that here, I'm going to have v ln natural logarithm of 3 minus x times the derivative of root x, which is 1 over 2 root x. If you apply the power rule to x to the 1/2, you have 1/2 x to the negative 1/2, which is 1 over 2 root x. So this is vu prime plus u, which is root x, times the derivative of ln natural logarithm of 3 minus x. This we have to use the chain rule since we have a linear function as the input function of the logarithmic function. Okay, we have a composition situation here. So the derivative of the outer function is going to be 1 over 3 minus x, because the derivative of ln u is 1 over u, and u is 3 minus x, times the derivative of the inner function 3 minus x. You have to be really careful here. That derivative is negative 1. Okay, but because the derivative of 3 is 0, and the derivative of negative x is negative 1. Alright, let's go ahead and simplify that. We're going to have y prime over y equals the natural logarithm of 3 minus x over 2 root x, that minus root x over 3 minus x. To get y prime isolated, we'll multiply both sides of the equation by y. So multiply this by y, and multiply this entire equation by y. So our final answer, the derivative y prime, is equal to, now we're going to put in the initial value of y for y here, which is 3 minus x raised to the root x power. That times the natural logarithm of 3 minus x over 2 root x minus root x over 3 minus x. Okay, so there goes your final answer for the derivative of y. All right, let's take a look at question number 2. So question 2, we have the function y equals, this is number 2, y equals cosine x raised to the 5x power. Okay, excellent candidate for logarithmic differentiation because we have a function raised to the function. All right, so first step, as usual, is to take the natural logarithm of both sides so we can power down this function or exponent. So natural logarithm of the left and natural logarithm of the right, natural logarithm of cosine x raised to the 5x. Okay, so using the power property of logarithms, I can power down this functional exponent right there. So we're going to have the natural logarithm of y equals 5x times the natural logarithm of cosine x. Okay? Now we're going to use the product rule on the right, and on the left side we're going to use the chain rule and implicit differentiation. If we differentiate L and y, we're going to have 1 over y, and then differentiating implicitly, we still have y prime. Okay? Equals, now in this case here, we already went over what the product rule is, so we can call this u, and then call this entire expression ln of cosine x, call that v. Okay, let's leave the 5 outside. So leaving the 5 outside, we can have vu prime, so ln cosine x is v, the derivative of x is 1 times 1, plus u, which is x. The derivative of ln x, we're going to use the chain rule. If we differentiate the parent function, we'll have 1 over u, or 1 over the input function, 1 over cosine x, times the derivative of the input function. The input function is cosine, its derivative is negative sine x. Alright, so let's go ahead and simplify that. We're going to have y prime over y equals 5 times the natural logarithm of cosine x minus x sine x over cosine x. Alright? Okay, now let's multiply both sides by y. So if I times this by y, and I also have to multiply this side by y. On the left side, I'm going to have y prime, because these two y's cancel out, equals, we're going to have 5. Let's use the commutative property of multiplication. I can switch the order here. 5y is cosine x raised to the 5x. That was the original value of y in the problem. Now, that we're going to multiply by times the natural logarithm of cosine x minus sine over cosine using the quotient identities is tan x. Okay, so there goes your final answer for the derivative of cosine x raised to the 5x. All right, let's try another example. Question number 3. What if we have y equals x raised to the sine 2x? Okay, now let's do the apply logarithmic differentiation here. So we take the natural logarithm of both sides. Natural logarithm of the left equals the natural logarithm of the right side, x to the sine 2x. Now using the power property of logarithm, I can power down this exponent, which is a function. Power that down. And that's going to yield the natural logarithm of y on the left stays the same, equals sine 2x times the natural logarithm of x. Now what we're going to do, we're going to apply the product rule for the product of the trigonometric and logarithmic function on the right side. On the left side, we're going to use chain rule and implicit differentiation. Okay, so if I do that, I'll differentiate ln y. We know the natural logarithm, the derivative of ln x is 1 over x, so the derivative of ln y is going to be 1 over y times y prime. Okay, and in this case here, let's call sine 2xu, and then call the natural logarithm of x v. So we're going to have v, which is ln x, u prime. The derivative of sine x is cosine 2x, all right, times 2. We're going to use the chain rule here. You do the parent function is cosine, keeping the inner function fixed, 2x, times the derivative of the inner function 2x, which is just 2. Okay, so we have the natural logarithm of cosine 2x times 2. So this is vu prime. I'm going to add u v prime. Alright, so u is sine 2x. And then v prime is the derivative of ln x, which is just simply 1 over x. Okay? Alright, let's simplify this more. We have y prime over y equals 2 ln x cosine 2x plus sine 2x over x. Now multiply both sides by y to get y prime isolated. Multiply this by y and multiply that by y also. So that's going to give us y prime equals, now y is x, the original problem, x to the sine 2x. And if you note here, I can factor out 1 over x from both sides here. So if I factor out 1 over x, from here you're going to end up with 2 times the natural logarithm of x cosine, actually 2x. So you have 2x times the natural logarithm of x cosine 2x. And the other one would just simply be sine 2x. Alright, so cosine 2x plus sine 2x. Alright, so some of you might wonder what just happened. Well, you can imagine that if there is no x here to factor out an x, I could put an x over x, right? And if I factor out the x's in the denominator, this will lose the x in the denominator, this will lose the x, but there'll be an x remaining there. That's the x that I put over here, okay? So if you want to check your work, you can just simply distribute 1 over x to everything here, and you're going to end up with the original expression you had upstairs, okay? So factoring it out, 1 over x like that. Next thing I can do is I can write it as, let's change the color. I can write it as y prime equals sine, equals x to the sine 2x, x to the sine 2x, and I can express 1 over x as x to the negative 1, and that whole thing times 2x times the natural logarithm of x cosine 2x plus sine 2x. Alright, and then to finish it up, I can use the product property of exponents to, combine the exponents on this product right here since the bases are the same. So y prime is going to be x to the sine 2x minus 1. This whole thing multiplied by 2x times the natural logarithm of x cosine 2x plus sine 2x. Alright, so there goes the derivative of y equals x to the sine 2x using implicit differentiation. Alright, logarithmic differentiation. So there you have it. So thanks so much for taking this time to watch the presentation. You can feel free to subscribe to my channel or post a comment to let me know what you think, and click like if you liked it, and feel free to share it with your friends via whatever social networking program you use. More math clips can be found on mathclips.com. Thanks again for watching, and have a wonderful day.